Hello, AP Macro students, and welcome to AP Daily Live. My name is Matt Romano, and I'm coming to you from Atlanta, Georgia, Marist School. And I'm humbled that you would join me today to go through this first of 8 lessons to review all of AP Macro. Let me take just a second and explain to you what the plan is with this program, with AP Daily Live, and then we'll jump right into the content. What you're going to find with the review sessions that we're going to go through over the next 8 nights is really a combination of things, 2 goals. We're going to take some time to go through and review the major content, the most challenging content that you have covered over the course of this year. And we're going to take close to half of all these review sessions to do that very thing. We can't get to every little thing, all the minute details that you have spent so much time on over the past however long you've been working on it. That's what your teachers have done and have done so well, I'm sure. What we're going to do is get the big stuff. Talk about what gets asked a lot, talk about approaches to those topics, and hopefully clarify some of those topics as we go. Every bit as important, though, the other half of our videos, and these will be back and forth throughout each video. The other half of our videos will be working on skills, practicing the skills that you have learned as you've gone and learned the content for AP Macro. What can you do with this knowledge? That's ultimately the question we want to ask. And it's really important that we ask that and address that, because AP Macro, any economics course, is not just about memorizing and regurgitating a whole bunch of facts. It's about learning facts about reality, about the world around you, and then being able to apply them. And while that's true for the AP Macro exam, it's also going to be true when you're out of school and dealing with the real world and trying to understand what's happening around you. So what we're going to do here, what we're going to do for the next 8 review sessions is, yes, review content, hit the big parts, work on definitions, work on what these concepts are all about, but then look at what we can do with it. What kind of applications are there, and how do I best apply this? Yes, for the AP exam, but even more so in my life ahead. And before we get into the content itself, I want to go ahead and point out one skill that you're going to see come up a lot that you may not have considered. What I consider to be one of the more underrated skills in all of AP Macro, and that's basic economic literacy. And here's why that is. The way I view this course, I see this course as an invitation to the adult outside of school conversation about the economy. And you, at this point in your academic career and your life, you need to be a part of that conversation. But if you're going to talk the talk, you've got to know the terms, you've got to know the words, you've got to have some degree of economic literacy. That's the first skill that we're going to focus on and that we're going to make sure we have moving forward. So keep that in mind as we go. You're going to hear that come up a lot one way or another. So what are we doing today, specifically today? Today, we're going back really to Unit 2, and we're going to focus on the major macroeconomic indicators. That's the content we want to focus on today. And I don't want to take anything for granted, especially with the concept of economic literacy in mind. I want to make sure before we even start that we all know what is an indicator. What does that word mean? Well, we're talking about indicators of economic activity, major indicators of economic activity, what they mean, what they represent, and then how we can calculate and interpret them. And as far as this course is concerned, at this point, at this stage in your class, it should be obvious what we're talking about. We're talking about what I like to refer to as the big 3 indicators. We're talking about GDP to represent output, inflation as a representation of price stability and what's happening with prices, and of course, unemployment as a representation of the employment situation. That's the focus in terms of the major macroeconomic indicators. And that's a common thread that runs all the way through this AP Macro course. And of course, you know that by now because your teachers have taught you that. The skills that we want to work on how do we calculate, how do we interpret this data? And as you well know, it goes beyond just GDP, inflation, unemployment. There are going to be related calculations that we have to be able to make. Now, on that point, there's another message I want to send to you. And this is just what I would consider a pro tip from having done this for quite some time now. There's a temptation to dive into the formulas and just try to memorize formulas, plug in numbers, and here we go. And I understand that temptation because sometimes working with data can be a little bit intimidating. I want to encourage you, especially now when you have a little more time to review, to stop, pause, breathe, and make sure you understand your terminology first. And if you do that, I promise you, you're going to find that in many cases, knowing the terminology is going to help you with those formulas that you're so concerned about. Because in many cases, and I'm going to try to point this out some today, in many cases that those definitions are going to give you the formulas themselves. So keep that in the back of your mind. That's something I have found, my students have found to be very helpful over the years, and I'm hoping you will as well. So let's get into it. Let's talk about these major macroeconomic indicators one at a time. We're going to review one at a time, practice each as we go, and then we're going to finish up by looking at an old FRQ, an old free response question from a prior exam, and see how we do with it. First one up, let's make sure we understand output. This is the biggest of the three, not necessarily most important. I don't think that's fair, and that's a little too normative anyway, but it's the one we probably hear the most about. We hear about it in terms of measuring what the economy is. We hear about it in terms of comparing economies. So we want to know something about output produced by an economy. And the number we look for is that number representing GDP, gross domestic product, the total amount of goods and services produced by an economy in a given year. Again, the definition is important, but the word almost defines itself. Gross means total. Domestic means here in this country, product represents output, gross domestic product. Know what it is, and it's a whole lot easier to calculate. Calculating GDP, on the other hand, can take a number of different forms, and we want to address that as well. There are really three different ways to calculate nominal, that being current dollar value, nominal GDP. The first and most common, the one that you're going to see the most in AP Macro, the one we're going to practice in just a moment, is the expenditures approach. That's used for national income accounts in the United States. That's used for most of the questions you're going to see in AP Macro. So what does the expenditures approach do? The expenditures approach is going to calculate GDP by counting up all the money spent on those domestically produced goods, subtracting money spent on imported goods. So what you need to recall when you start talking about expenditures approach is the money spent on goods produced domestic. If you're talking about United States GDP, the money spent on US produced goods. And I think the easiest way, at least for me, the easiest way to remember that is to think, who is it that's buying these goods? Well, you have households, consumers. You have businesses, that's investment. You have government, they buy things as well. And then you have the rest of the world, that's net exports. And we subtract out as a part of net exports those imported goods. And if you recall CIGNX, then you can calculate GDP with a set of expenditures data. We're going to practice that in just a moment. Before doing so, though, let's touch on those other two versions. The income approach. The income approach is going to look at the other side, where the expenditures approach is going to look at money spent on those finished goods. The income approach is going to count up all the income earned, which is a way of really counting up money spent producing those goods. So when we use the income approach, which is not as common, both out there in the world and in AP Macro, when we do count up GDP using the income approach, we're going to be counting up rent, wages, interest, and profit, those being payments for those resources that we're going to be using to produce. The final is the value-added approach. And the value-added approach, as you can see here, calculates GDP based upon values added along each step of the production process. So we're looking at a production process and we are progressively adding value as we go. This one we don't see nearly as much, but we need to be aware that it exists. We need to know that it's another option in terms of calculating GDP. So all that said, let's turn our attention back to the expenditures approach and let's practice one real quick, just a simple little practice problem to tune us up for that FRQ coming later, because you never know what could come up. So here's an example of a way a calculating GDP question could come about. Assume that you have a table, and this table represents GDP data for a particular economy for a particular time period. Let's just assume for 1 year. And these are nominal amounts, but in the current dollar values. And what you may be asked to do is take data like this and sift through it and determine what counts, what doesn't count, add it up to determine what the nominal GDP happened to be at that particular time. The way we're going to do these practice problems, I'm going to present it to you, give you a task, and then I'm going to ask you to pause it. I'm going to put this little pause symbol up here and ask you to pause this video so that you have enough time to work your way through the problem and then come back when you unpause it, and I'll go back through the answer and how we got there. So go ahead and pause, take a second here, take a beat, work your way through, calculate nominal GDP, and then when you come back, We'll work our way through the answer. Okay, I'm going to assume that you're back from practicing that problem, and I'm going to get rid of pause. So what are we looking for? Another theme you're going to hear from me in all these videos. Before we can answer any problem, we have to define the problem. We're trying to determine what counts and what doesn't count before we can add anything else up. So what counts when we're calculating GDP using the expenditures approach? Well, we just said it: consumer spending, investment spending, government spending, and net export spending. So I've got to work my way through these little categories, and I've got to determine what among this would count as one of those four. Let's work our way down. Household spending. Household spending is pretty basic. That is consumer spending. We're going to count that $10,000. Second one down, fixed business investment, also pretty obvious. The word's right there in it. That's what investment spending is, among other things. Financial assets, the purchase of financial assets. This is something you did in Unit 4, but it could have come up back in Unit 2 when you first learned how to calculate this stuff. The purchase of financial assets, does that count as part of GDP in the expenditures approach? It does not. Strike it out. It doesn't count because it's not the production of any good or service. The purchase of a financial asset does not represent the production of a new good or service. We don't count it. Exports, obviously, exports count. They're part of net exports. How about intermediate goods? Again, this is one of those details we didn't get into in this video, but it's something that you addressed a long time ago in Unit 2. Do intermediate goods count? Spending on intermediate goods count? No, they don't. Scratch them out because intermediate goods are part of the process of producing. So when we're using the expenditures approach, spending on intermediate goods is not going to count. Residential investment spending. Well, what is that? The word residential tells me that's spending on new homes. Does that count? Yes, it does. That's investment spending. What about non-market activity? We're estimating $6,000 worth of non-market activity here. That's activity that may have served a productive of a good or service, may have produced a productive good or service, but there was no exchange, no transfer of funds, nothing that was actually recorded. And as a result, we can't count that. How about transfer payments? Transfer payments are payments for, well, not really anything. They're payments that don't result in the production of a good or service, and as thus, does not count. Scratch it. Imported goods. Imported goods count. They're part of net exports, but what do we have to remember? They're a negative. So we're going to have a subtraction of 3,000 at the end. Government purchases, obviously, that's government spending. And then additions to inventory. What is inventory? Inventory would be goods that were produced but not sold in a given year. So the question becomes, should it count? Yes, it should. Where do we put it? We put it in investment spending. So additions to inventory are included. They're included in investment spending. And when I take all those numbers, scratch the ones that don't count, we should get a GDP of $18,000. That's a very basic question, but it's one that we see from time to time. So you've got to, again, understand what counts, what doesn't count, what are CIGNX, and how to identify what I'm going to include when I calculate GDP. Well, what's next? Let's continue reviewing. Understanding price stability. You know, we as consumers, we as businesses, whomever it is in economy, typically would prefer stable or relatively stable prices. So the question becomes, how do we know prices are stable? It comes down to an understanding of inflation. So once again, let's start by defining what is inflation. This is a word, and oftentimes because of what we learned maybe in history classes or somewhere else, this is a word that's easy to misunderstand. When you see the word inflation, all we're referring to is an increase in the general price level. So prices are rising. What caused it? What happens as a result? These are important, and we can get into those later on. But in this context, we just want to know an increase in the general price level, as opposed to deflation, which of course is a decrease in the general price level, or, easy to confuse, disinflation, a decrease in the inflation rate. So make sure you can distinguish between these three concepts. Inflation simply means that the general price level, the average price of goods, is going up. Living got more expensive. My grocery bills got more expensive. Everything is going up in price. With deflation, it's the opposite. Prices are falling all over the place. Average price of goods is going down. With disinflation, we still have inflation, just less inflation than before. And it's really easy to confuse those terms. Those terms do come up, especially in multiple choice questions, and we need to make sure we understand a difference between the three. Now, We are typically referring to inflation because we typically have inflation. Deflation doesn't occur very often. How do we calculate it? How do we analyze it? Let's talk about that. Inflation rates are typically going to be calculated through a price index. And it's worth discussing why that is, what it is, and why that is. The CPI is a great example, the Consumer Price Index, which I'm sure you've learned about. We hear a lot about the Consumer Price Index in the media, through economic communication, because it's a market basket of goods representing typical consumer purchases. So the index number that we use, the CPI itself, represents that average price of consumer goods. So as we see it fluctuate up or down and are able to measure that rate at which the price index goes up or down, we get a sense of that overall average price level and whether it's increasing or decreasing, whether we have inflation, deflation, or disinflation. What again is a price index? A price index is a representation of prices in a market basket of goods. Think of just a big basket full of similar goods, goods that are purchased together. In the case of the Consumer Price Index, we're talking about, again, typical consumer goods. That consistent basket of goods is going to be measured from one time period to the next. And in doing so, signals to us what's happening to the price of goods classified under that category. How do we do this? How do we construct a price index? How do we use that price index to calculate inflation? Let's take a look. Okay, a couple practice problems here. First one, constructing a price index. Here we have a generic basket of goods. Okay, I didn't even name the items. I'm not that creative, I guess. We have items A, B, C, and D. To be a credible price index, we have to have a consistent set of items. And we have to have a consistent quantity. If your quantity varies, you don't have a reliable, measurable basket of goods. So we have to have that consistent basket of goods from one year to the next. Now, this is a very small basket of goods, obviously. Keep in mind that when you're talking about something like the CPI, it's 80,000 plus items. It is a massive index of items. It's a big old basket. Here, we have a very small basket. That's used for teaching purposes. It's used to give us a chance to understand what we're talking about. The first stage in constructing a price index is going to be constructing the basket price for each individual year. So here you have 4 years. And as you can see, just by glancing at the table, in each of the 4 years, some prices, if not all, some prices have changed. So something is happening out there in the market causing the price of goods to change. And what we want to be able to do is see that change in prices. So step one, again, simply calculate the price, the market value of each basket in each year. So let's start with year one. All we're doing is multiplying price times quantity and adding them up. So item A, there were 10 units of item A purchased at $5 per unit. That means they're going to spend $50 on item A that year. For item B, there were 5 units purchased at $5 per unit. Item C, 20 at $5 per unit. And for item D, 10 at $5 per unit. So how much is being spent total? Well, you have $50 on A, $25 on B, $100 on C, and another $50 on D. Add those up, and the value of the basket in year one is going to be $225. Jump to year two, which says base year. We'll come back to that in just a moment. And we see that items B and D went up in price. We don't know why. This doesn't tell us that. That's what supply and demand is for. We just know the price went up. A and C stayed the same price. So with a fixed quantity, what should we expect? We should expect the price of the basket to go up. And we go through and do our math and find, yes, it does. The same basket, the same quantity of goods goes from $225 in year one up to $250 in year two. Jump over to year three, and the prices go up again for 3 of the 4 items. C is holding steady at $5. Add those up, and you're going to get a $275 basket. So once again, the value of the basket, the dollar value of the basket is increasing each year. And as we jump to year 4, you'll see 3 of the 4 once again go up in price. Item B goes down, but when you look at it as a whole, the price of the basket goes up to $330. Now, that's not an index number yet. All we have at this point would be the actual values of the basket itself. And these numbers are easy to work with. They're 3-digit numbers. It's a 4-item basket. Very, very simple figures, I know. We could use these to calculate inflation. We're still going to convert these numbers into index numbers so we can get used to the process and understand how it's done. The reason those index numbers are so helpful when we talk about the CPI is because, again, an 80,000 item basket is going to have a much larger, much less manageable figure, and converting it to a 3-digit index number makes things a whole lot simpler. How do we make that index number work? How do we convert? How do we calculate that index number? It's a very simple process. Said it earlier, year 2 is labeled as our base year. That's an arbitrary thing. We could pick any of the 4 years that we wanted to be our base year, but we decided we're going to go with year 2 as our base year. That means that we're setting up a ratio to compare the market value of each basket to year 2, our base year. So all I have to do at this point is take the market basket for each individual year, divide it by the same basket in the base year, and I have my index number when I multiply it by 100. So in doing so, this is what I get. The price index for year 1 is 225 divided by 250 times 100, meaning I have a price index of 90. For year 2, I take my year 2, divide it by the base year, also year 2, multiply it by 100, and I get an index number of 100. That's important. For obvious reasons, we're always going to have an index number of 100 in the base year. For year 3, 275 divided by 250 times 100, I get 110. And for year 4, my market basket of 330 divided by the base year 250 times 100, 132. Okay, so now I have my index numbers. How do I go from index numbers to inflation rate? That's where we want to get, because inflation ultimately, or deflation, if it were to happen, that's the number I'm looking for. So let's go there. Calculating inflation is simply calculating a percent change, a very basic calculation of percent change. What I like to use is just a very, very basic, essentially mnemonic device. New minus old over old. Commit that to memory. New minus old over old times 100 is going to give you percent change of anything. In this context, we're looking at the percent change in a price index, which represents the percent change of a price level. You may need this somewhere else. At some point, you may need to calculate the percent change in real GDP. You may need to calculate the percent change in real GDP per capita. This is basically a life skill. We should be able to calculate percent change. So this, using these index numbers that we just calculated on the previous slide, is going to allow us to calculate the percent change in prices from one year to the next. So what I'd like you to do right here is, once again, pause. I'll wait for just a second. Calculate your inflation rates for years 2, 3, and 4. Obviously, we can't do year 1 because we don't have a year 0. But calculate the inflation rate, that being the percent change for years 2, 3, and 4, and then we'll come back and look at those answers. Okay, I'm going to trust you're back from pausing. You've done your work. Let's take a look and see what we found. From year 1 to 2, using new minus old over old. The new price index was 100. The old one was 90 because we're going from 1 to 2. So it's year 2 minus year 1 divided by year 1. That gives us 10 divided by 90. Multiply that by 100, and you're going to get roughly 11%. I know it's a repeating decimal, but we'll go with 11% for now. And by the way, when you're taking your exam, they're going to be not much cleaner numbers than that, much like this second one. If we're looking to get the inflation rate for year 3, we take year 3 index number 110, subtract year 2 because that's the old one, divide it by year 2, and then multiply by 100. 110 minus 100 divided by 100 times 100 is going to give you 10%. Now this is nice. This is convenient. We like this. Anytime we're finding percent change from the base year, it's basically just a subtraction question. It's going to come out to that number. The 110 minus 10 is 10. It's going to be a 10% answer. Be careful though. If we get too accustomed to that, we start to think that every one of these is a basic subtraction question, and it's not. We have to be aware that the scale matters. For example, year 4. Year 4, we had an index number of 132. So we're taking 132, subtracting year 3's index number of 110, and dividing by 110. So that gives us 22 divided by 110, multiply that by 100, and you find a 20% increase in the price index, meaning we had 20% inflation. So those percent changes, those numbers that you got right there, those are your inflation rates for years 2, 3, and 4. It's a simple percent change. If you know how to do that, you can find inflation or deflation or disinflation. What's next? Let's continue reviewing. We said there are three major macro indicators or situations that we want to be able to work with. Let's talk about that third one. The third is the employment situation. Now, I said earlier that GDP is the biggest one, but this might be the one we hear about the most, especially in politics and definitely in the media. We always hear about the unemployment rate. Let's make sure that when we hear that number, when we hear it in the news, we hear discussion of it, we know what it represents, because a lot of folks out there may not quite understand what that number represents. So start with simply the unemployment rate. What is the unemployment rate? We know it's a percentage. It is a percentage of the labor force that are out of work, yet seeking employment. And those distinctions are very important. It's not a percentage of the total population. Let's not make that mistake. It is a percentage of the labor force, and that makes a big, big difference. If you're talking about the United States, labor force may only be half of the total population. Another number, though, another little piece of data that you've got to know for this course, and you really want to know for out there in the world, is the labor force participation rate. We want to know, of all those eligible, of all those who could be in the labor force, how many of them actually are? Because that's going to tell us something as well. That's going to tell a story about who's actually, as it says here, who's actually participating in the employment situation. So in this case, we're looking at the percentage of eligible, that being adult workers, the eligible population actually in the labor force. And we need to understand what that means. The general, when I talk about eligible adult population, the general phrase for that is going to be the civilian, non-institutional population age 16 and above. You will see that phrasing from time to time because that's the phrasing that's used in national income accounts in the United States. A little more about the employment situation. Let's make sure we understand some more terminology before we jump into the numbers. What does it mean to be employed? I know that seems very simple. It is very simple, but we have to address it and make sure we understand it. To be employed means you currently have a job. I know, couldn't be more obvious, but we have to point out, it doesn't matter if it's a full-time or part-time job. There is no distinction here. Both are counted the same. And this is sometimes considered to be, I don't want to say criticism, but a limitation of that number of unemployment, because it doesn't give us the full picture of what's actually going on in labor markets throughout the country. If you have a large amount of part-time workers, you may just have a large amount of underemployed workers. Regardless, they're counted the same. We need to know that because it's going to affect the way we calculate things. To be unemployed, again, seems obvious, but let's make sure we understand. To be unemployed, you're out of work, but you're also actively looking for work. If you're not actively looking for work, you're not unemployed. You very well could be what's called a discouraged worker. You're not in the labor force one way or another. Maybe you're marginally attached. You very well could be what's called a discouraged worker. You were looking for a job, couldn't find one, no longer looking for it. We have to, again, make that distinction. That comes up in the data. It comes up in FRQs. It comes up in multiple choice questions, but even more so, it comes up in the real world. And we need to understand, once again, what do these numbers represent? That's another, sometimes cited as, limitation of the unemployment rate. It's leaving out people who are not going to be looking for a job. And that, to some degree, underestimates what's actually going on. So finally, the labor force, I keep referring back to it. What is the labor force? Well, in this context, it's merely the sum of the employed and unemployed. And when you're looking at data, again, the way it's oftentimes presented in AP Macro, that's how we calculate it. Let's work with this a little bit. Let's practice it. Before we do so, we need some formulas. So calculating the labor force participation rate, as I said to start it out, in many ways, the definition is the formula. The labor force, if you know what it is, the labor force participation rate simply tells me of all those that are eligible, how many are actually in the labor force. So we're taking the labor force as a percentage of that total adult population. Unemployment is simply the percentage of the labor force currently unemployed. By this definition, currently unemployed. So actively seeking employment. All right. The last thing before we get to the practice, A quick reminder about the natural rate of unemployment, because we need to be able to not only define, but also find this as well. The natural rate of unemployment is going to be that unemployment rate that occurs when the economy is operating at full employment levels of output. So we're assuming that all resources are fully employed. This is a direct reference to labor because we're looking at the employment market. I'm sorry, the employment situation. If we're looking at data, we know that the natural rate of unemployment is going to be that rate where there is zero cyclical unemployment. So it is only frictional plus structural unemployment. When we're at full employment output, the current unemployment rate is equal to the natural rate. At all other times, it's the natural rate plus whatever cyclical unemployment we happen to have. Understand those distinctions, and you can make the calculations necessary to interpret this data. All right, now let's practice. I got a little ahead of myself there, but now let's practice this and make sure we know how to work with these numbers. So here you have, again, an example of how data may be presented to you. And again, this may be in an AP macro FRQ, or this may just be an economic report that you're looking at from the Bureau of Labor Statistics. It could be either. You've got to be able to look at this data and interpret what you're looking at so that you can then make those important calculations about what's happening and therefore understand a little bit more about the employment situation. So given just this data, can we calculate unemployment rate and labor force participation rate? And if so, what do we need? Think back to the formulas, think back to the definitions. We need to know how many people are employed, how many people are unemployed, how many people are in the labor force. Start with those employed. You're going to have 675 people employed. How do I know? Because it includes both part-time and full-time. So I'm going to take those two rows, add them up, and I have the number employed. How about unemployed? Unemployed is going to be 75,000. We're going to calculate the actual unemployment rate. And when that's the case, we're including all three types of unemployment. So frictionally, structurally, and cyclically, those are all going to be included. 50 plus 10 plus 15 is going to give me 75,000. Those 250,000 marginally attached, they do not count. We don't know what their situation is. We're assuming they're not looking for a job. They're not going to count in the official measure of unemployed. From there, we want to know the labor force. Add those two numbers together. Your labor force is going to be 750,000 people. What do we do with this data? Well, what we'd like to do is calculate the labor force participation rate and the unemployment rate. So using this data, we want to be able to do just that. Let me pause for just a moment, or you pause for just a moment, and then we'll see how we did with it. So calculate your labor force participation rate and your unemployment rate. Okay, I'm going to trust your back. Let's see how we did. To find the labor force participation rate, we're taking the labor force as a percentage of the civilian non-institutionalized population. That means we're taking 750,000, dividing it by 1 million, and we get 75%. For unemployment, we're taking the number unemployed as a percentage of the labor force. So that's 75,000 divided by 750,000, and we should have gotten 10%. We're going to come back to those numbers soon. We're actually going to come back to this exact same data pretty soon here and look at how we can further analyze it to learn even more about the economy. All right, so let's keep moving. We've got our big three indicators now. We've discussed those big three topics: output, price stability, the employment situation. So we have a basis of understanding them. Now, what else can we do with these things? What other kinds of questions can we be asked, and what else can we interpret about the world around us? Well, one of the big ones that we do in AP Macro that we have to understand is converting from nominal GDP, which we did with the expenditures approach, to real GDP, which means we're making an adjustment for the effects of inflation. We're making an adjustment for the fact that prices have changed from one year to the next. To review, nominal GDP is telling us how much money was spent in a given year. Real GDP is going to tell us how much output was actually produced. Real GDP is the one we want to know. That's the one that gives us an accurate year-to-year measure of output produced. Because as we'll see in just a moment, nominal, because it doesn't make any adjustments for inflation, nominal can be skewed when inflation occurs. And it does not give us a reliable source of a change in output from one year to the next. So we've got to know how to make this conversion work. And doing so is going to require us to use more than one of those indicators that we just learned. It's going to require us to use not just nominal GDP, but nominal GDP and a price index. The formula you want to use in very general terms is going to be nominal GDP divided by the GDP deflator. Now let's be very clear about this. The GDP deflator is a specific price index. It's a price index made up of those items that are included in GDP, conveniently so. And it's really a ratio of nominal to real GDP. So we're going to use that number to convert nominal GDP into real GDP. Here's an example for you. Assume you have calculated nominal GDP of $12,000. And at that same time, that GDP deflator, that GDP price index essentially, tells you that we have a GDP deflator of 150. How do I calculate real GDP? Pause this for a moment, do your calculation. We'll come back and check. Okay. I'm going to take that data. I'm going to take my $12,000 nominal GDP. I'm going to divide it by 150 and multiply it by 100. And we should get a real GDP of 8,000. So how much was actually produced? What's the market value of what was actually produced? When adjusting for the effects of inflation, we're going to get $8,000. Now, what just happened there and why do we care? We can go a step further, look at this in a slightly different direction, and understand the answer to those two questions. Why do we make that conversion? Why do we go from nominal to real GDP? As I said before, prices change from year to year. And when prices change, those prices, those dollar values, that's our unit of measurement for GDP. And if the unit of measurement has changed from one year to the next, the GDP data itself is going to be distorted. So we have to adjust back. We need a consistent unit of measurement in order to see the changes in output from one year to the next. That's what happens when you convert from nominal to real. You're basically, remember the concept of base year? You're basically converting all dollar values to a consistent base year value. That way your unit of measurement is consistent from one year to the next, and now I have a consistent measure of output from one year to the next. Without doing so, I don't have that measure. Nominal GDP can't do that for me. So I've got to make the conversion from nominal to real. That's the true indication we're looking for. And if we want to see real GDP, if we want to see percent change in real GDP as an indication of output growth, we have to do that. We have to make that conversion. Let's look at it another way. Here's a really small economy. They produce three goods: apples, bananas, and cherries. It's a fruit-based economy. Here's the data from that economy for 2 years, year one and year two. As you can see, the prices increase from year one to year two, but the quantities don't. So if you're down there on the ground, if you're on the farm and you're looking at how much is being produced of apples, bananas, and cherries, you're going to see that the exact same amount was produced. But if you took the data presented here and merely calculated nominal GDP by combining the prices and quantities of each, it's going to look like GDP went up a ton, doubled. Now, is that true? Did output actually double? Well, it's pretty clear looking at this basic data that it did not. But the number we got for GDP, which is supposed to represent output, doubled. What if the prices didn't change? If the prices didn't change, if we stayed at year one prices, we would find real GDP didn't change as well, an indication that total output did not change. So because we are measuring output in dollar amounts, we've got to make this conversion. We've got to convert from nominal GDP to real GDP to better understand the actual change in output that occurs from one year to the next. What else can we do? Well, this is the exact question we just did. We calculated the labor force participation rate. We calculated the unemployment rate. But what else can I do with this data? Well, one other thing we can do, one thing we should be able to do in the scenarios presented in AP Macro is take employment data and from that be able to conclude what kind of output caps possibly exist. To do so, I need to know the natural rate of unemployment. So let's start with that. How do I calculate the natural rate of unemployment? Well, again, definitions. Go back to your terminology. What is the natural rate of unemployment? It's simply frictional plus structural unemployment. So in this case, if I wanted to calculate the natural rate of unemployment, what am I going to do? I'm going to take the frictional plus structural, 60,000, drop cyclical, because it's not included, divide by my labor force, and I get a natural rate of unemployment of 8%. What does that tell me? We'll compare that to the actual unemployment rate. And what I find is now I have an unemployment rate which is greater than the natural rate. That's going to tell me that we have an output gap. Now, later on, if you continue watching our review videos, we're going to talk more about ADAS. That's the heart of the course. That's the model we use to represent all that stuff. We should be able to take this data and illustrate it on a model of ADAS, and we should show that when unemployment is greater than the natural rate, we're going to have a recessionary gap. So just looking at the data right here, we can make that conclusion because we know that's the case when unemployment is greater than the natural rate. All right, let's look at an example. How is this presented on the AP macro exam? We've done a lot today, and I appreciate you hanging in there with me because there's a lot to do. So we're going to limit it to just one FRQ here. It can be asked in multiple choice questions. Make sure we understand that as well. But I want to look at the most recent example of an FRQ where data like this was presented and had to be interpreted. So this is from 2018. This is the third FRQ from 2018. Going to walk our way through it. I'll read it to you. Then we're going to pause, and I'm going to give you a chance to do the question, and then we'll go back through the answers as we've done with all of our practice. Countries face trade-offs between producing consumer goods and producing capital goods. When you read an FRQ, there's always this statement at the beginning that's going to tell you something you need to know. It may seem obvious, and this is kind of obvious, I know. Read it, pause, make sure you understand what was said because they're going to tell you something you need to know. So make sure you're reading the question and you're defining the question as you go. Part A, country X takes 1 hour to produce a unit of consumer goods and 2 hours to produce a unit of capital goods. Country Y takes 2 hours to produce a unit of consumer goods and 4 hours to produce a unit of capital goods. Which country has a comparative advantage in the production of consumer goods? Explain. Now, we didn't talk about this concept today, obviously. As I said, we can't talk about every concept every day, but this is something that you've done. You did this all the way back in Unit 1. We should know how to calculate comparative advantage. My pro tip for this, make sure you write down your data. I like to use a table. Write down, make your own little table and organize your data so that you know what they're telling you in this initial prompt so that you can accurately respond to the question. Next, the following table shows labor market data for country X. Okay, enter the big three. Here's one of your big three, and here's one way it can be presented. Look at your table, define what you have before you try to answer everything. Understand what you're looking at. So you've got 180,000 people that are employed. Didn't make a distinction. Full-time, part-time makes no difference. They're employed. You have your numbers for frictional, structural, and cyclical unemployment. 10,000, 5,000, 5,000. And then you have a number for not in the labor force. Those could be discouraged workers, marginally attached. It could be a lot of things. All you know is these are people that are in the population, but are not included in the labor force, therefore not included in our calculation of unemployment. So part B, calculate the unemployment rate in country X, show your work. Part C, calculate the labor force participation rate in country X, show your work, which means you have to show your work. At the very least, show how you set up the equation. And then finally, D, draw a correctly labeled graph of the production possibilities curve for country X with consumer goods on the horizontal, capital goods on the vertical. Indicate a point on your graph labeled Z that reflects the current level of unemployment. How are you going to know that? Pause for just a moment. Go ahead and answer the question and we will go over the answers. Okay, I'm going to assume you're back and that you have gone through the question. You have answered all the parts. Let's look at our answers. Parts A, B, and C. These would combine to be 3 of the 5 points on this question. Part A was your comparative advantage question. 1 point is earned for stating that neither country has comparative advantage, explaining that the opportunity cost of producing 1 unit of consumer goods is the same for both countries. This is an option. Let's keep that in mind. I know when this was asked the first time, many students were surprised. If no one has the lower opportunity cost, no one has comparative advantage. Part B, 1 point earned for correctly calculating the unemployment rate as 10%. You should have got 10%. There were 20,000 unemployed. We can go back and look at that. 10,000 frictional, 5,000 structural, 5,000 cyclical, 10,000 unemployed out of a labor force of 200,000. How'd you get to 200,000 in the labor force? You had 180 employed, 20,000 unemployed, 180 plus 20, 200,000. And then finally, 1 point earned for correctly calculating the labor force participation rate, 66.67%. That was your labor force of 200,000 divided by the total population of 300,000, of course, times 100 because we're dealing in percentages. Finally, part D, you had to draw a production possibilities curve, a correctly labeled production possibilities curve. So we have capital goods, we have consumer goods. It didn't state whether we had constant or increasing opportunity costs, so you're safe here with a constant opportunity cost, that being a linear PPC. And then you had to get 1 point. You earned 1 point by showing point Z below the PPC. How did we know it was below the PPC? Again, go back and analyze the data. The existence of cyclical unemployment tells us what? The current unemployment rate must be higher than the natural rate of unemployment. We have a recessionary gap. We are operating an output level below full employment, hence point Z. One more pro tip when it comes to taking the exam. This sounds like such a simple thing, I know, but you need to know this. Make sure you follow the directions. If it asks for point Z, make sure you use the letter Z. Don't just arbitrarily choose a different letter. We don't know what you're talking about. So if it asks for point Z, put a dot, put the letter Z as you see right here. What do we take away from all this? Well, we have three major macroeconomic indicators, and they tell us something about three very important parts of any economy: output, price stability, the employment situation. We need to know them by definition first so that we can then properly calculate and interpret data. And if you start with the definition, it's going to make working with the data that much easier. I can assure you of that. I want to thank you for watching today. I want to thank you for being a part of this journey, this AP Daily Live journey. I do encourage you to come back. We're going to be doing this for 8 days over the next 2 weeks. And I thank you for doing it. I'm humbled that you would come and watch. And in the meantime, I would ask you, thank someone for giving you the opportunity to be a part of AP Macro. Thank your teachers for all the hard work they put into it. And thank them for me, because I appreciate the work they're putting into it as well. I do hope you come back for our next lesson. And in the meantime, have a great day. Thanks a lot.